Hello, everyone. Welcome to the session. And this is basically going to be a top to bottom rundown on a head-to-head between Amazon AWS and Microsoft Azure. I'm Darius Victorious. I'm a cloud architect with Cognizant Softvision. And hope you're enjoying Programmers Week so far and learning much from this. We have a lot to cover in this session. It's a 90-minute session. But we will definitely have a lot here to go through. We're going to stop in the middle of the session, take any questions that you have, and then we'll continue on and we'll get additional questions at the end. So hold your questions if you can. There'll be opportunity for you to ask them. I've basically been doing this professionally for about 25 years. I had the fortunate opportunity to write my first line of code as a young child on the original IBM 8088 that happened to have access to, a relative of mine, and have loved computing ever since. I started a consulting firm in '97. I've been certified in Microsoft since '96, and certified on both clouds. I've done this from small businesses to nonprofits to Fortune 100 enterprises. Continue to do so. I've done this in both a hands-on and a management capacity, even to senior leadership. And the cloud was just so interesting to me that I had to get back into a more hands-on tech role. And I hope you can share the same passion about the cloud as well. But there's going to be a lot of good information in this session for multiple aspects of individuals, from developers to systems engineers, architects, decision makers. And whether you're new to the cloud, whether you're using one of these two clouds and you want to learn more about one or the other, this session is definitely going to be for you. So our agenda today, we're going to go, and for those of you who have not been using the cloud yet, we are going to define why you might want to use the cloud, or maybe you've got some questions in that regard as well. We'll talk about the different service models for cloud computing, the costs and licensing involved. We'll then talk about geographies. It's actually a pretty critical topic because the cloud is theoretically everywhere, and we need to understand where we're deploying our application workloads and our systems to for best cost, return on our investment, and also performance for our end users. We'll talk about security differences between both of these clouds, and then we'll also look at the services side by side, like some of the high-level main services. We just don't have enough time to cover all of them. There's literally over 150 services per cloud to discuss, and we just don't have the time. Hopefully we'll have some time to cover the differences in storage between the two, because I actually believe it's very not well understood aspect of the two clouds, and I think that it would be really important for you to understand those differences. And then we'll hopefully crown a winner victorious. So let's talk about why we would want to use the cloud. The adoption of these two clouds, by the way, I wanted to touch on why am I not going into Google or any of the other offerings. And you can just see by sheer percentage of respondents at an enterprise level, and this holds true even for the small and mid-sized businesses, you'll see the vast majority will be either using Amazon or Microsoft for their clouds of choice. Now, Google has been increasing in these responses. Last year, when I gave a similar presentation, Google held about 2/3 of the responses, as you see here for this current year's survey. But we are definitely going to be focusing on the two primary ones. I wanted to talk about why the cloud is important, and you'll notice a massive adoption for cloud even since COVID struck, right? So I'm sure, as you can imagine, you've got all the virtualization requirements, putting things in remote work capabilities for collaboration, this Zoom session that we're currently using right now, right? So there's a much need for the cloud. It's not as easy to get to your local office, obviously, or a co-located data center as it once used to be, at least during this COVID outbreak. So you can see the adoption between small and mid-sized businesses in the enterprise for the cloud. Now, some have actually cut back. And so we'll talk about why some have decided to actually cut back on the use of the cloud as well here in just a bit. But in general, the cloud is allowing us to do things remotely and allow us to do things potentially less expensively if you're smart about it. And we'll talk about that here in just a couple minutes. So looking at the different service models, when you're doing stuff on premise in your own environments, whether it's co-located or in your facilities, these are the different layers of the stacks that we can have hosted, from the hardware at the very base, the raw hardware, the bare metal as it's called at the bottom, all the way up to the functions running inside of our applications. And when we look at the service models, we can basically break them out into these different tiers. And so what you'll see here is the color delineation that I've created for you to differentiate what you maintain within your environment versus what another individual or another team might maintain, right? So on premise, the virtualization and the hardware might be maintained by your systems engineering team, and things from the operating system on up might be maintained by a DevOps team or an application team. Usually starts to get involved somewhere around between the operating system and the runtime. So that's kind of a sliding ruler. But as we go into the cloud service models, we have something known as infrastructure as a service. You may have heard of IaaS, and that's what infrastructure as a service is defining. And what you see here is you start to see an abstraction where the gray area, the gray blocks, the virtualization and the hardware layers here, those tiers are completely abstracted from us. We don't have access in the cloud to actually control the virtualization layer, whether that be VMware, Hyper-V, or some other type of hypervisor. We don't have access to that, right? We don't have access to the hardware either, nor do we start to have access in infrastructure as a service to the operating system, because it's basically a virtual machine that's been configured for us, that deployed, that we can basically go ahead and log into and start to work with. And you might do that, or you might have a systems engineering team doing that. The 4 tiers above that, are still within our purview, within our control as well, for an application to be hosted upon. Now, container as a service, which is less used moniker, we'll talk about platform as a service here in just a second, but container as a service abstracts the operating system away from us and provides a hosted environment to run containers such as Docker containers, which is the predominant type of container out there. And Docker containers can abstract us away from the operating system. It also provides sandboxes, if you will, for us to run our applications in a secure manner and allow them to interact as well. You'll see that we can also still have maintained control above that. And there's platform as a service, where effectively a platform as a service is an application type environment. We don't control the runtime, we don't control or decide the container types, et cetera. And so we have platforms as a service. There's also another type, which is really a SaaS or software as a service. It's very similar to PaaS. It's just that we don't deploy our applications, right? We're consuming someone else's application. So if we take these 3 cloud types, there's a 4th. It's you may have heard of serverless compute or serverless computing. That's functions as a service for the most part. So functions can basically be deployed to make up our application. And you'll notice that the colors are inverted. They're inverted because the application itself is a space that our application team is obviously architecting and deploying and holistically through a microservices architecture, combining to basically go ahead and actually host. But individually, those functions and the actual execution of them and the details of those might be left, interestingly, curiously, to more of like a DevOps role, not necessarily the application developer themselves. So the execution or the hosting of that function is outside of the developer's purview in a larger environment, okay? So the cost of the cloud, this is super important. People think of the cloud, it's gonna save me money, but they might start running in the cloud and realizing that it's actually quite costly. And you have to weigh how much cost you're spending on electricity, how much you're spending on conditioning, air conditioning, all that. And also the cost of the hardware, of course, and hardware becoming antiquated. But outside of that, 30% of surveyed respondents said that they believe 30% of their cost, rather, of all the respondents, 30% of their costs or spend in the cloud, they consider wasted. And it's wasted because they're not making use of the tenets of the cloud to actually make it cost effective. And so what does being in the cloud actually mean? Dr. Nicole Forsgren on Scott Hanselman's Hanselman Minutes podcast about a year and a half ago or so stated that through a survey that they did, they were discussing her white paper report, the state of DevOps, and they determined that only 22% of respondents that are actually using the cloud were truly working in the cloud. And what does that really mean? That means that they're not making use of some of these tenants in the cloud to really make it cost effective. So on-demand self-service is the ability to basically, provision services and resources as we need them, and also to deprovision them. So you can actually get rid of them when you don't need them. They can come up for temporary use and be done away with. The network access, what does that mean? Think of it like you can actually deploy things closer to the user. So they're actually having faster experiences, to your application as opposed to just hosting your application in one location. Resource pooling, so you can have, the gathering of multiple servers, the multiple, database servers, et cetera, and pool them together so that you can also, scale elastically. So you've heard of the cloud being elastic. The elastic cloud is the ability for you to increase and decrease what you're doing in the cloud. You might change the size of your database services or the size of your web services, how many instances you have, what scale are they capable of handling, and do this all elastically. You don't need all of the services online at the peak performance in the middle of the wee hours of the night, in a particular time zone. So you can scale them back and you can actually save money, and that's measured services. So you can measure your services and keep them under wraps and costs under control by making use of some of those approaches. There's different cost models in the cloud. There's on-demand and also known as pay-as-you-go models inside of Azure. Those are basically pay-as-you-go. If I'm going to consume something by the minute or by the hour, I'm going to pay for it. Whereas reservations allow us to prepay and commit to a year or up to 3 years of a particular tier of service for a database or for a certain server size for our web servers or our API servers, and allows us to go ahead and actually have significant cost savings to the tune of as high as 73% cost savings off of list. I can't stress enough how few customers will actually make use of these until we get engaged and actually help point them in the right direction. So you really want to keep in mind that there are reservations out there that you can prepay and make use of, and even split the cost of a reservation across multiple instances and save substantially. And that goes also for licensing. So there's licensing that's provided by these vendors for Windows operating system, for Red Hat Linux, for SQL Server and other databases, et cetera. But you can also bring your own license. And in the case of AWS, some of those parameters have changed a bit. If you bring your own Windows license, being that they're not Microsoft, you can only use that license for dedicated machine instances. What are dedicated instances? They're effectively a single virtual machine running on physical hardware that's been dedicated strictly to you. There's no other virtual machines from any other customers shared on it, and you can bring your Windows license. SQL Server, what changed there is you can bring SQL Server licenses to your virtual machine instances inside of AWS, also known as EC2. But they discontinued SQL Server for their relational data service, for their fully managed database solution. And that was because of a change from Microsoft. Microsoft introduced something known as SQL Server Managed Instances, and they withheld Amazon's ability for you to bring that license. Now, on the Microsoft side, you can bring in Windows Server licenses through something they call a hybrid use benefit. So not just for your bare metal dedicated compute machine instances, but you can also bring it for all of your virtual machines at a substantial cost savings there. Same thing with SQL Server. You can use your on-premise or even acquire SQL Server licenses that you would have otherwise used for your on-premise and actually dedicate them to your Azure environment. And again, the cost savings can be up to 73%. So here are, I want to take a step back and just say, you know what, let's look at the cloud geographies. We talked about the importance of this and the fact that there are some pretty substantial differences between both clouds. So in the case of regions inside of these geographies, they're known as regions, and they're separate locations for data centers. So for Amazon, a region from another region, like you'll hear US East, you'll hear US West, Central US, etc. Each cloud names them differently, but for all intents and purposes, they're data center locations. And for AWS, they're at least 800 miles apart. For Azure, they're at least 300 miles apart, so a little bit less distance there, but we'll cover the differences here in just a second. There's also government cloud options from both providers for your needs for that sector, and then there's also options within China as well. So we have a raised hand, and I will definitely take your question. Maybe our host can respond to Galaxy M30, and we'll take your questions here in just a few minutes. Okay, so please hold your question if you joined late. So differences by region. We have basically the varying differences in each region from a standpoint of what services are available to you to actually go ahead and host. So there's something called Ultra SSD or Ultra Disk, for example, from Azure. It's not available in all regions. The simple email service for AWS is not available in all regions. And so there's certain services that are not available. Others are available across all of them. Costs will also vary. So for example, hosting on the West Coast, your footprint, hosting your application on the West Coast, because electricity costs more and there's some higher tax rates there on the West Coast, those Western regions will actually cost you more for practically all services. Predominantly compute will cost more because of the electrical consumption there. So looking at the large map, here's the AWS global infrastructure, and you'll see that there's 24 regions specifically right now, with a couple more coming soon. This is the footprint for AWS. And when we advance this slide over into Microsoft, which I'll do now, there's 58 regions. So naturally, we're going to conclude, and Microsoft uses it as a big marketing push, that there are substantially more regions available to you to host your workload. And while there's some truth to the fact that they have regions located potentially closer to your customer, closer to where your workload needs to be consumed, I will go through some details here that will actually break this down for us. Note that in these blue circles, you'll see some regions with a white diamond in it. Those are regions that have something called availability zones. So you'll see the availability zones over here, like Central US, East US, and East US 2, and West US 2, for example. Those are regions, data center locations. Remember, a region is a data center location that has more than one data center in that region. So availability zones are basically data center infrastructure itself, like the physical building. So within a region, you can have multiple data centers. And for AWS, they're 50 miles apart typically. And for Azure, they're often on the same plot of land, or very, very, very close, not typically 50 miles apart. Now, 50 miles apart is close enough to not have any issues with network performance. You can still have very fast network latency, for that connection within the same region for AWS, and for Azure, of course, being on the same plot of land. But we need to keep in mind that there's some differences between these clouds, okay? So, for example, in general, Azure regions that have availability zones, and remember, I showed you that there's a few that have availability zones. Not all of them have availability zones. And that was something new that Azure Microsoft introduced in 2018. from demand due to outages, and it was at a time when AWS was leading in terms of reliability. That is no longer the case because Microsoft introduced availability zones. But keep in mind that you will have only certain regions in Azure that support availability zones at this point, whereas in AWS, all regions support it, okay? And also, all services in AWS support availability zones, while in Azure, only a limited set do. So by the numbers here, and this is basically information that I gathered up a few days back by making some API calls and trying my best to deduce the current count. So if I don't have access to government cloud data center accounts, so all I did was basically make use of the ones that we are publicly able to access through our logins, right? So the total regions, as we saw for AWS and Azure, 24 and 58 respectively. The amount with availability zones, of course, AWS has that many regions with availability zones, and Azure has fewer. But let's look at the total data centers. So like if we look at like the total availability zone data centers, right, across all of the regions that are out there, you'll start to see that the playing field is leveled out pretty substantially. And the claim that Microsoft has more than double the regions is not quite you know, the reality. The reality of it is that if I want a redundant location with multiple data center buildings in the same general region, same general space, they both have about the same amount of data centers. So one thing that's important when you select a region is determining the network latency from your customer, your end user, even if that's you for your own corporation or organization, and the actual data center that you're presently looking to host your workload in. So the last thing you want to do is have someone in Australia accessing Seattle, for example, because you're going to have a large 250 millisecond delay with every single network packet that's traveling over the internet from your cloud environment to your customer. So you want to definitely bring the workloads as close as possible to your customer base. There's also a concept of paired regions. Paired regions in both clouds allow you to, and we'll make this recording will be available, by the way, when we're done with this. So some of these details and everything, you'll be more than able to go back and reread these slides verbatim. But basically, if you can run certain commands in the command line interface, you can also look at documentation that will actually describe for you and show you and define the paired regions. So paired regions between two regions are effectively like the partner regions, the failover regions that each cloud provider uses for their redundancy, for their database services, for all of their other services. And for example, in Azure, it's East US pairs with West US, and East US 2 pairs with Central US. So there's some geographical differences in the paired regions that you need to be aware of, and just keep that in mind. My preferred regions for both clouds are the AWS Ohio region, which is known as US East 2, and Azure Central US region for the Microsoft Cloud Platform. There's several reasons for this. This map right here shows you the different power grids across our country, and you'll note that basically by using Azure's Central US region, you can actually get into a different power grid altogether than the Eastern Seaboard, and hopefully you know, isolate yourself somewhat. There was a big blackout, if you recall, in the Northeast back about 18 years ago. I want to say 17 years ago, and it affected, I believe it was the pink grid that you see here. If not, no, actually, I think it was crossing over between the yellow and the pink grid a little bit. But it's important to keep in mind, you know, where your workloads are. For Azure as well, that region, Central US, happens to be where a very large footprint is for the Office 365 platform. So if you're making use of any of the Office 365 services and applications, teaming with your apps, that might be a good choice for you as a primary region. And this would basically be where you might want to store your primary region. You still need a secondary region, ideally, just to isolate yourself. Azure has something different than AWS, though. They allow you to even place some I'd say a pretty decent amount of the services that they offer onto your on-premises environment. So if you still have, your office location, or you have a region that has data sovereignty concerns, like Luxembourg, for example, you might want to host your own Azure stack. And that allows you to basically fully manage the physical infrastructure, know that it's on your premise, the data is not leaving your location, but you can fully manage it using the Azure portal and host those services locally. There's also something that Microsoft introduced, which was the Azure Stack for first responders, which is basically an entire Azure stack running out of the back of a Suburban. And this was designed to help bring AI and the power of the Azure Stack closest to disasters such as hurricanes and so forth. So we're going to do a quick demo, and then we're going to take a few of your questions. So let's go ahead and actually take a look here real quick at these demos. So in order to discover your latency, there's two different, well, there's several out there, but these are two that we're going to touch on, is cloudping.info and Azure Latency. Both are used to use HTTP to actually go ahead and determine the latency from your location to every single region, public region, in Azure and in AWS. In this case, we are looking at AWS. And you'll see that my closest region from a ping standpoint is clearly Virginia, US East 1 as it's called, Ohio just slightly behind there, US East 2, and of course the West Coast opens that up further. So as you can see, you definitely don't want to host your workload in Europe, right? If your customers are in the United States, and the vice versa. And data sovereignty issues aside of where your data needs to be hosted, clearly there is going to be a delay in the latency in using those regions. The one here from azurespeed.com, this Azure Speed Test, is pretty neat. You can select different regions inside of Azure and go ahead and actually have it report on an ongoing basis and give you the average latency with the top 3 regions that it considers closest to you. So no surprise, Virginia, again, is closest to me. And you'll see this list kind of vary as it goes. If you really want to have a very clear top 3, I would say quickly identify which ones are closest to you. There's no reason for me to keep, including other regions that are, for example, West US. It's obvious that that's further away from me. So we'll just look at these top 3, and you can see, that clearly Virginia is still a winner. So Virginia might be where I want to host my workload, followed with Central US as a close second. All right. So we'll go ahead and close these demos out real quick, and we'll come back here and we'll take any questions that you have so far. So Rose, I will hand it to you.
We have one in the Q&A model. It says, you mentioned best server locations in the US. What about in Europe? Or should we never choose Europe, even if your customers are in Europe?
Oh, no. Definitely, this is just what are my favorite locations inside of the US. And I apologize, but if I go back, let's go back and look at the actual map of the different regions. So it's really going to depend upon where you're located. And in Europe, obviously we have to be aware of the GDPR and some other regulations. So be mindful of the fact, with how the UK's recent exit from the EU might impact you there. You may not want to host it in UK or in Europe or vice versa, exposing you to certain, regulations or restrictions on data sovereignty. Ultimately, what you'll want to do is you'll want to look at the breakdown, and both providers have a chart that you can look at which services are available in which region, and ultimately what might make your mind up to decide a specific region within your general vicinity is which services are actually available in those regions. You might find that certain services that you desire are, for example, available in Northern Europe, but they're not available in Western Europe or vice versa. So hopefully that answers your question.
We have another one. Is
Sure.
the latency the most important thing we have to care about? What about price and services?
So all of them, so all of the aspects that we discussed, right? And I just mentioned that certain services are only available in certain regions. And earlier in this presentation, may want to go back and look at the video. We talked about the fact that cost can be a factor. And so costs do vary within Europe and within the United States and other, geographies as well. So cost will definitely potentially be a factor. And in some cases, that cost difference can be as high as 20%. On certain services. So you'll definitely want to look at that, but do look into reservations. You really need to look into reservations. Once you've established what level of service you need, what size of database server or what size of virtual machine or app service, and get yourself a reservation so that you can actually reduce your costs substantially in either cloud.
No more questions so far.
No more questions, great. Okay, so let's go ahead and actually jump forward to the next section.
Sorry, so there's one more in the chat. I just saw it.
Okay, go ahead.
Do you have a bandwidth relative map, like latency one?
Do I have a what map?
A bandwidth relative map.
Bandwidth relative map. You're gonna have to test, as far as total bandwidth coming out of these particular regions. Microsoft has that documented, and AWS, I believe, has that documented somewhere. It's literally in the terabits per second coming out of regions. And theoretically, your bandwidth coming out of it is unlimited. You just get charged for, by the way, you get charged for data leaving the cloud, going back to the customer, going back to you, downloads, page views from your web server, images being served up. So you want to make sure you're using caching where you can so that the customers are caching images on your website or your web apps, etc., mobile apps. But you don't get charged for data coming back into the cloud. Anything you upload into the cloud, transfer into the cloud is not charged. Bandwidth is charged leaving the cloud to the customer. But as far as bandwidth latencies and things like that, like I just said, I just showed you 2 examples of tests that you can run to do latency tests to see which regions are closest to you. Any more questions?
No, you can go ahead.
Okay, great. So let's talk real quick about security in the cloud. There are key differences between these 2 providers. So ultimately, you have your native identities that you log into the cloud with, that you manage the cloud with, and that you can assign permissions to different services inside of the cloud. And so in AWS, it's known as Identity Access Management, or IAM, and in Azure, it's the Azure Active Directory, which is a software as a service offering from Microsoft. It's a kind of a superset of Active Directory that you would otherwise host inside of your local environment. In the case of traditional Microsoft Active Directory offered as a service, so platform as a service offering, AWS has their AWS Directory service, which is Active Directory basically running inside of their own managed virtual machines. And Azure has AD domain services. When you are coding or developing an application to be logged into, you could obviously roll your own identity, but you could also use a cloud identity. So these app dev directories that we have here, the Amazon Cloud Directory and the Azure AD B2C, or business to consumer or business to client, those are specifically from the ground up directories that have been created by both providers for you to integrate your applications with, for your customers to be able to have a login with a unified identity, similar or akin to, say, a Google ID and things of that nature. And you can provide that identity integration to those 2 cloud providers. You could also integrate with Azure Active Directory directly, but the B2C version in Azure is definitely used for applications specifically. One thing that you'll want to always make sure you do from a security standpoint, don't put your applications inside, don't put your application secrets like passwords to a database or encryption keys or things of that nature. Don't store them inside of your application or in configuration files or even in your database. There are security vaults that is known as the KMS, or the Key Management Service, and the Key Vault from Microsoft as well, where you can store with even hardware grade encryption. You can store all your secrets and all of your keys and everything and access them securely from your environment there. Definitely don't store your secrets in clear text. There's some differences in data encryption between the two. In AWS, you have to be cognizant of enabling encryption in certain services, such as the disk storage. It's manually enabled. So you have to manually enable something called encryption by default, which means I want to, by default, encrypt everything inside of my cloud environment from a disk storage standpoint, but you have to turn that on. In Azure, it's automatically enabled for their managed disks and for all of their storage, blob storage and everything else that we'll talk about in just a little bit. So those are some key differences I would point you to. The security model between both clouds is also critically different. In AWS, your organization of security and how you inherit access into the environment and your resources is a little bit, shall we say, it's evolved over time. AWS introduced a couple years ago an organizations concept. An AWS organization is one or more AWS accounts where you can have a master account and child accounts underneath it. So you have your organization's master or your parent and your child accounts underneath it, where you would basically have delineation or boundaries of security. So if you, for example, go and deploy a certain type of workload, something called Elastic Beanstalk, in order to deploy that workload, you have to have pretty elevated rights inside of that AWS account. And that individual or that service that's deploying your Beanstalk environment may not and should not have full access necessarily to your entire organization and your entire enterprise. And so you can't necessarily granularly control and sandbox in a certain workload inside of AWS without using an account as your boundary, as your security boundary. So keep that in mind. In AWS, accounts are your security boundary because you really can't sandbox in certain types of environments like developer environments as seen here in this particular example here at the bottom left. You can't sandbox in your developers within the same account. You've got to create different accounts that are separate from your production workload accounts. And AWS even encourages you to break this down further. So your billing is in one account, which you can do. And you can store your logging resources in another to ensure that certain logs don't get deleted and purged out, etc. So accounts are your friend in AWS. It gets a little bit involved. It gets a little bit, there's some overhead there, more than I'd care for, but it's the right way to go. So make sure you make use of that. In Azure, it's a different approach. It's a top-down inherited approach, similar to file permissions on a computer, where you can set permissions at the disk level, at the folder level, or a subfolder, and then ultimately your files themselves. So if we think of it in that way, in Azure, we can set permissions at the subscription level, or what's known as a resource group level. So think of those as folders, or the resources themselves. Think of those as the files inside of those folders. And this allows us to very easily inherit access down. It also prevents us from having to create separate accounts and structure them inside of something like an organization in the case of AWS. So we can have a single subscription, or you can have multiple subscriptions, and it might be good to have multiple subscriptions for your workloads or to further compartmentalize non-production from production workloads from billing standpoints. But ultimately, a subscription is a billing construct. So a subscription allows us to easily track our costs from, say, production versus non-production, or European versus US workloads, et cetera. And resource groups allow us to group together those resources, just as the name implies, and do security on those and basically sandbox in those resources. And we can also granularly give access to resources individually as well. Not that you can't do that in AWS, but meaning grant access at the resource level, but certain types of resource environments will require you to grant elevated access at the account level, or in this example, say the subscription level, which is simply not the case inside of Azure. You can grant access at the resource group level and allow that entire environment to run within that resource group with those security constructs. So when we talk about security side by side and the tools available side by side for managing and for monitoring both clouds, in AWS, it's called the Management Console. In Azure, it's called the Portal. And we have, those are your graphical user interfaces through web interfaces. You have command line interfaces as well, where you can do scripting. And to be honest with you, as you become proficient with either cloud, you will want to use a scripted environment, as your management platform, because it's just so easy to deploy or roll back or deallocate your resources through a script and have that become a repeatable process. So you don't have to sit there and manually configure everything. You can always go back into the user interfaces and see what you created and even interact with them. But ultimately, scripting is your friend. So if you're not familiar with scripting from a command line for PowerShell, for example, which is a predominant means of scripting both clouds, I would encourage you to look into that. Both clouds also have a CLI tool, which is basically a command line tool for issuing commands in a batch file, but the PowerShell libraries are very powerful. There's also what I'll call a captured or a captive shell in Azure. It's called the Azure Cloud Shell. It's a really neat environment. If we have time, I'll show it to you just for like 30, 40 seconds when we do a demo. But basically the Cloud Shell is a really great in the web browser, in the Azure portal way of doing PowerShell and other commands without you having to install anything on your local machine. And it just automatically authenticates you because you're already logged in. So there's something known as infrastructure as code. And infrastructure as code in a mid and a large size environment, especially an enterprise environment, is very much where you want to be focused on for deploying your workloads. You don't want to go and use the interfaces. You may not even want to script everything because it can become very verbose. But resource templates in the case of Azure Resource Manager templates, ARM templates as they call them, and Cloud Formation templates in AWS are a means through JSON or YAML notation to basically go ahead and define templates, and there are samples available, which you'll see. There's a way for you to quickly deploy your workloads inside of either environment and deploy them very quickly. So it's a great tool. Definitely something you're going to want to look into. And I see we have some raised hands. Please do ask your questions in the chat session, and we will definitely be answering them here again in a short while. So monitoring and alerting. So CloudWatch is what you use in AWS. Azure Monitor is what you use in Azure. And then curiously, a blob storage tool. So blob storage is binary large object storage inside of an HTTP endpoint, which basically is, for all intents and purposes, think of it as a web server that's hosting storage for you. But the Azure Storage Explorer is available from Microsoft. For AWS, you have to use third-party tools. So let's run through some of the primary side-by-side services, side-by-side, some of the primary services available between both clouds. So we talked about infrastructure as a service where you run your own environment. You have to stand up your own virtual machine and so forth. At the core, there's networking. In AWS, it's known as a virtual private cloud. In Azure, it's called as a VNet or a virtual network. There's compute, so EC2 for virtual machines. In AWS, they call them virtual machines. In Azure, in the actual storage that you connect to your virtual machines is called Elastic Block Store, or EBS, or EBS in AWS. In Azure, it's just called Azure VM Storage, also known as Azure Disk or Azure Disk Storage. And name resolution is DNS, basically, right? So your domain name service. I always loved when I first looked at AWS and several years back, 5 years ago or 6 years ago, when I started with AWS and I first came across the Route 53 service. I had to chuckle because I actually have a pretty extensive networking background as well, infrastructure networking and routing. And 53 is the port number that DNS, the domain name service, uses to respond to at the TCP and UDP level. And so I really thought that was a neat name for a service. But Route 53 is AWS's DNS service, and Azure is called Azure DNS. They have load balancers, as you can see, so you can put your virtual machines behind a load balancer for redundancy and for scalability. We also previously defined what a container as a service is. And so these are the different offerings between the two clouds for container hosting and running your containers. So you have these like cloud native environments, which are fully managed by the cloud provider. You upload your containers and they run them for you, like Elastic Beanstalk and Azure App Service, which I'll show you a quick demo on. Hopefully, I think we do have time. I will do a demo of launching both environments. You can host containers there, or you can run apps directly. There's also a cloud agnostic approach to containers, which is known as Kubernetes. And Kubernetes is basically an orchestration service you may want to look into that both not only AWS and Azure, but even Google, who started and pioneered the Kubernetes orchestration, offers as part of their platform for hosting containers and spinning up all the compute and all the virtual machines and all the storage behind the scenes that you need to host your environment without you having to worry about all those details. If a environment goes down, it rebuilds itself, it adds, it scales, it subtracts. It's pretty impressive. It's a kind of a DevOps. It's a DevOps, field of expertise there. But if you don't have a DevOps team, or you do have a DevOps team, you definitely want to look into Kubernetes. Because it is cloud agnostic as well. So platform as a service, services that are managed by each cloud provider for you, right? So as we talked about that earlier, there are marketplaces or service catalogs which allow you to deploy the platform managed services from like a marketplace environment. You can see all of them and basically use those templates to deploy your environments. Blob storage, we talked about a little bit earlier, HTTP, HTTPS endpoints that allow you to store large amounts of data and store them redundantly. S3, which many of you have probably heard of in AWS. In Azure, it's known as blob storage. And then we have app hosting environments, which are fully managed by Microsoft. They take care of the virtual machines for us. In that case, it's App Service from Microsoft. In Amazon, it's Beanstalk, Elastic Beanstalk. There's other offerings as well. I'm just talking about the best known options inside of both clouds here. Cache services are available, as is email, except for Microsoft. So remember I talked about there are some differences between these clouds. So we had Azure gives us the Cloud Shell, which is a great management feature, but unfortunately, Azure does not have an email service. The simple email service that AWS has is bidirectional. So you can actually send email through SES. You can even receive email through SES and tie that into your application. So that's actually a powerful feature in AWS, which unfortunately Microsoft has no equivalent. You can roll your own email server or email service, but not out of the box. Event notifications are used for creating notifications from your own applications, as well as the infrastructure, the entire environment, the entire platform. So you can get notified when certain things go down or come back up, services. So functions as a service that we talked about earlier. So serverless compute, where we can host our functions for our application across both clouds. In AWS, it's called Lambda. In Azure, it's very uniquely called Azure Functions. And as you can see, this list is very closely transposable, at least for the first four first four languages are able to basically cross over. But this list was a lot shorter, just a year or so ago. They've continued to make progress there. And databases in the cloud. One chart that I didn't show, which I've given in different talks before, is just how much database in the cloud is a demanded service. Naturally, we need to store data, right? But the primary thing that customers are driving for when they come to the cloud is they don't want to manage the entire infrastructure that is necessary for their database. So they basically often will choose the cloud to not have to manage that infrastructure because there's some tricks in there. I've been doing SQL Server for over 20 years, and it's a passion of mine. And I love SQL Server in general, but it's tricky to get it to run efficiently and effectively and perform well. So using these database as a service, really our platform as a service offerings for databases, can really help us scale our cloud, hosting of these databases. So these are the different options available. In the case of SQL or relational data, there's a relational database service from AWS, and there's different varieties that they can host, right? They can host Microsoft, Oracle, MySQL, Postgres, and they also have a unique flavor, which we'll talk about, is Amazon Aurora, which is basically a self-developed, Amazon-developed platform for relational databases. That's a database as a service that can run MySQL and Postgres workloads. So you choose for a specific database, I want it to use the MySQL model or I want it to use the Postgres model. And that's a great offering there as well. In the case of Azure, they have the Azure SQL database for Microsoft SQL compatible workloads. There's a lot behind these two bullets, behind single DB and elastic pools and managed instances. Just know that a managed instance is the closest you'll get to basically a full SQL server that's fully managed for you in the way that the relational database service from AWS hosts Microsoft SQL Server. So an Azure SQL managed instance is a traditional SQL server. A single DB and elastic pool Azure SQL database is not your traditional SQL server. It is an optimized database in the cloud platform. It has a subset of TSQL. I mean, most of it's supported, but it is a subset. And there are some benefits to it. For example, they actually have the ability to optimize indexes for you automatically on the fly to improve your workload performance and so forth. So you don't have to be a DBA to get decent performance out of your SQL database anymore. So there are options there as well. And we see that Azure also has options for Mariah, MySQL, and Postgres that are hosted for you. From a document or NoSQL database standpoint, of course, you can run Mongo on either platform in a virtual machine, but you can also run Mongo in a managed environment as well. But the cloud native options for NoSQL between these two clouds, as you can see, is Amazon SimpleDB, DynamoDB being the graduated version of SimpleDB with substantially increased service availability, and it has a multi-master model now to compete with Azure's Cosmos DB. So really, if you want to have the ability to have a multi-master global, very low latency, redundant replicated database, you would choose Amazon DynamoDB or Cosmos DB. And AI in the cloud, there are individual components, as you can see on the bottom of this list, that make up different aspects to AI or machine learning inside of the cloud. And these are the different options that are available to us for different things like image recognition, voice recognition, face recognition, etc. And all of those components, and there are more than these are the main ones, they roll up into, you can either consume them directly in your app, or you can build them, build an environment, build a model, train a model, and deploy it for hosting in AWS's SageMaker or in Azure's machine learning environment. So there is a one-stop shop, if you will, from both cloud providers for that. So we're going to go into a demo, but I'll go ahead and just open it up real quick to questions if we have any, which I'm sure we do.
No, we don't have any questions.
Okay, I saw a couple of raised hands, so I just thought we might have them. That's great, because that gives us time right now to get into the demo. So we're going to look at the console, AWS console, and the Azure portal side by side. So here is the management console for AWS. When we first log in and we land here, we'll see, you know, basically typically a getting started screen, which I've already cleared out. We can see my account up here in the top right, you know, my actual account login. We could get into details of the billing and so forth and my credentials. And you can also see which region you're currently managing. In AWS, when you come and you manage your services, you need to be very mindful of which region you see specified up here, because the region that you have selected is the region that you're working with and in. Inside of Azure, you basically have a wide view of everything from one place. But in AWS, when you go to deploy resources, whatever region you are currently pointed at through this console or through the API is the region that you're going to deploy resources in. So just keep that in mind. You can look at all of the services here underneath. You can also see all the services by clicking here on the services list. And this list is very extensive. Not going to lie to you, right? So if we scroll down, you can see just how many services there are. And it seems like every other month there's a new service or two. And that is true. They are continuing to come up with more and more services. Some of them are, I'll call them roll-ups of other services. So they're not directly a completely separate service. They might be an abstraction of another service. Like I mentioned earlier, SageMaker, the machine learning environment that you have there, is an environment that rolls up and uses a lot of different machine learning services like, you know, Lex and Poly and so forth, where you can actually go ahead and make use of those different individual machine learning services. But you'll see that, you know, it's basically broken down by group and or, you know, alphabetically. So I would encourage you to not get overwhelmed by the cloud. The very first time that I started, I landed on here, and keep in mind that this list was maybe half or a third of what, I'd say a third of what it is now. And I was completely overwhelmed, and I said, there's no way I'm going to figure this out. And in full honesty and in full disclosure, I have probably only used a fraction of the services in both clouds that are available to us personally, because there just isn't enough time in the day for us to become, you know, a proficient in all of these. It is important as a solution architect to understand what all the different services generally do. So if you're in an architect's role and architect capacity, the certification exams are also going to be asking questions that will steer your answers based on the services available. But just keep in mind that there's no way we can figure all this out. Within each cloud provider, there are broken down certifications now, especially of Microsoft for database, for machine learning, for business intelligence, for you know, cloud application development, for cloud administration. And so whatever role you're in will dictate and drive which services you might be, you know, familiar with. So keep that in mind. So you can basically come in here and you can start deploying things manually. You could come into Elastic Beanstalk, and this is the application hosting environment where you could actually go ahead and host applications without having to worry about starting up a server and putting in a load balancer and all that stuff. It's all taken care of for you, just like it is in Azure. There's an application service, which we'll look at. And you could go ahead and actually create the application, specify the name, pick your platform. Is it going to be .NET Core on Linux? Is it going to be Node? You get to pick the platform. You pick the version within reason that they support, and you can go ahead and actually start with a sample application, or you can upload your code. And you can upload your code from a file that you might have, or from an S3 blob bucket that you have already uploaded your application code to. There are SDKs in both clouds that allow you to integrate from your IDE like Visual Studio to deploy .NET to either AWS or into Azure, but you can also deploy them through other means as well, through DevOps, through CI/CD pipelines in both environments. But the point is we can either manually create things through a user interface, or we can manually create them through a script in PowerShell, for example, or we can go ahead and actually use something called infrastructure as code. So we talked about infrastructure as code earlier, about CloudFormation versus Azure ARM templates. And what the beauty of the cloud is that we can very quickly create an environment, test it out. If it doesn't work, tear it back down, and barely have any cost, associated with that, because we brought it all up and tore it all down within 1 hour of billable time. So it might otherwise cost us $1,000 a month or $5,000 a month if we were running 24/7. It's going to cost us $5, for the hour, for example, to test out an entire environment if we need to, and tear it back down. So that's the beauty of the cloud, both from a production scalability standpoint and also from a testing standpoint. So as I mentioned, CloudFormation is infrastructure as code. So what this allows us to do is allows us to, in AWS, create something they call a stack. A stack is one or more resources that have been created and deployed in the AWS cloud using a template. And that template can be a JSON format or a YAML format template. And there's documentation on it. There's also Designer that you can use, which I'll show you here in just a second. But ultimately, when you use CloudFormation, you can actually go ahead and create things from a template and deploy them repeatedly to different environments and tear them back down and iterate over them. So if we look at a list of, this is the documentation for CloudFormation, and we have basically different services that we can look at here with sample CloudFormation templates for each one of these services. And since we're looking at Elastic Beanstalk, we have a couple different templates that we can look at, and we can launch an entire stack, just from here. So this example is an Elastic Beanstalk Node.js sample. So if we could view the actual template, which we'll go ahead and click on here, and like I mentioned, they're in JSON or YAML format. So this is JSON. And you can see that basically it defines the different regions that are available for this particular template that it can run in, what resources it has, what policies it might define, and a sample configuration template to deploy. In this case, it basically is going to deploy a Elastic Beanstalk environment with SSH access to a Node.js application running on 64-bit Amazon Linux. And basically, set up that environment for us and put some sample application code in there for us. Put in the sample base environment, for Node.js. So it's basically just firing up the default Node environment. And that's basically looking at the actual, raw template. Now, are you eventually going to understand that to that detail? Some individuals do. It's their job to understand these templates. It might be your job to eventually understand how to form a template, and many will actually form them manually. But you can also use a designer. So here in AWS, you can actually use a designer to look at the template and start building it. And you have a list of all your resource types on the left. On the bottom, we have the actual JSON that we just saw in the template represented, which you can manually edit. And you also have a full graphical user environment showing you all the different components that make up this environment that we're going to actually deploy using this template. And so this is, the designer where you can actually from here just go ahead and deploy this template out and give it the parameters, which we'll do, and have it go ahead and deploy this environment. Now, there's one thing that you need to understand here that I came across as I was preparing this demo for you, is unfortunately, things move very, very quickly in these clouds. So even Amazon in this case is having a little bit to play some catch up, I believe, in the sense that these templates that were included here refer to a Linux image that is outdated, that is no longer supported by Amazon. So what I had to do is I had to go through the documentation and find out which is the currently supported list of Linux environments for Beanstalk running Node.js. It wasn't that hard to find. Google is your friend. And basically came to discover that this 64-bit Amazon Linux string was incorrect. This is a 2018 image of Linux, and ultimately what I found, it wasn't the Linux version that was the problem. It's the Node.js version no longer being supported by Elastic Beanstalk. So 4.7.1 has been deprecated, and I had to replace this string with this value, 4.15 instead of 4.7. And that ultimately allowed me to deploy this. You'll see that my designer is out of date. I need to refresh this, so I'll go ahead and refresh this really quick. And now we could go ahead and deploy this template. So I'll go ahead and hit deploy, and it'll direct us to the screen and say the template, we're going to use the template that we were just editing. We could have it from an Amazon S3 location, or we can upload a template. So we could deploy it as is like this, and we could go back and view it in the designer that I was just using. I'll go ahead and just show you uploading a template because I have the ability to do that. I already have my template here with that fix in place. I'm uploading the template, so I could have designed it on my computer and put it up here for deployment. I'm going to hit next, and we're going to give this a name. We're going to call it PW 2020 Beanstalk, or why don't we just call it Node.js? So we'll do that. This is a key pair. So if you wanted to actually SSH into these Linux instances that we're deploying inside of Beanstalk, you would use this key file, which I created separately in a separate step and saved to my local machine here as a key pair to allow me to get into that Linux environment if I wanted to. And then there's some additional options. Tags allow us to manage resources in both clouds, so we can tag our resources. I'm just going to go ahead quickly and hit next. And we could estimate the cost if we wanted to with a calculator, but I'm going to go ahead and scroll all the way down in the interest of time and very quickly acknowledge that I realize that I'm going to incur costs and I'm going to have additional resources created. I'm going to start creating the stack. So right now, this is the stack that's being created. And you'll see that I had some other stacks that I created earlier and deleted as well. But this is the stack is presently in process. We could refresh the screen and we can see what it's doing. It's actually creating web server roles. It's creating a sample application. We'll see an Elastic Beanstalk environment start being created and so forth. But so for the interest of time, let's go ahead and let's jump over to the Azure portal, and we'll come back and look at this when we're all done. So this is the Azure portal, found at portal.azure.com, regardless of which region or environment you're in. Now, separate from AWS, as you noticed in AWS, we had to pick a specific region that we were operating in. That is not the case inside of Azure. When you deploy resources in Azure, you pick which region they're being deployed into based on parameters that you set. So that's one key difference. There's Azure Active Directory, which defines all your user accounts and so forth. There's virtual machine definitions. There are app services, which is the equivalent of the Beanstalk that we were just looking at. You can, as I've told you before, run .NET, Node, Python, etc. Basically, think of it as a managed web service environment. Storage accounts allow us to define where we store our disks and our blob storage and so forth, and SQL databases and so forth. And then you can go to a list of services. And similar to AWS, you have them categorized. You can also look at all the services, and you can see that there's a pretty substantial list of them. And this basically allows us to deploy things as granular as a network interface, or as as abstracted as an entirely managed service that we don't have to worry about. So don't get overwhelmed by this list. It's a learning process, and as I said, there's no way that any of us can understand what all of this does and become very proficient with all of it. Is just not enough time in the day. But what we'll do, for the interest of time, is we'll do something similar to what we did inside of AWS. We're going to go ahead and actually deploy something here inside of Azure. So Azure has something known as ARM templates, like I mentioned to you. They have quick start templates, which there's a community provided list of templates in here, as well as templates provided by Microsoft. And you can either create your own templates, or you can use one of these quick start templates. So one of the templates that I had found was this app service quick start, which basically just goes ahead and puts together an app service running ASP.NET and deploys that out, and we can actually go ahead and access it through a URL. And basically this just grabs something off of GitHub and deploys it. But we could do it manually, right? We could come back. Let me just zoom out on my way. But we could do this manually. We could come into an app service, and we could actually go ahead and create a new app service. Manually go ahead and pick these different values for which subscription we want to put it into, what resource group we want to put it into. Remember, Azure uses resource groups, so we can create a new one or have an existing one. And pick whether we're deploying code or whether we're deploying a Docker container. Is it Linux? Is it Windows? Which region do you want to place it into? So as I mentioned, in the case of, remember in Azure, you're always going to pick the region you're deploying in. And so we could do it this way. We could go manually and specify values, but we're going to go ahead and do the quick start here real quick. So we'll go ahead and deploy to Azure. And while we're waiting for this to set up, you can see that you can edit the template, and you can edit parameters to the template. These are all the parameters that the template is expecting right here. The region that you want to deploy in, is it East US, is it Central? We'll pick Central. You know what, let's pick East since it's closest to me. The web app name could be something that we manually specify, or you can see that you can provide some scripting in here to actually derive the web app name, in this case, from the actual resource group ID. So I could do that. I could derive this unique ID here, or I could specify a value. I'll go ahead and just leave this as is. We're deploying a .NET environment, and let's go ahead and actually create this real quick. We're going to need a new resource group, so we'll call it PW 2020 demo. And let's go ahead and create this. And it's just giving us a review. Yes, this is what I want to create. And you'll see that the deployment is now in progress. So as this goes on, it will refresh the screen every so often, or we can manually refresh it in the same way that you can in AWS, and you can see the different steps that it's taking to actually create the deployment for us. And this will take about 4 to 5 minutes, so we'll come back to that. Let's take a look real quick back at AWS and see where we're at with the deployment here. So we're actually finished deploying this sample template here. So let me go to the stack info here, and it says that create is completed. So we're completely deployed. So now you say, well, what do I do with this? You could manually go back into Elastic Beanstalk and take a look at it. You could also grab it here from resources. These are all the resources that it deployed. And we can see from here that there's an application here for Elastic Beanstalk. So I'm going to click on this. It's going to take us straight to the Elastic Beanstalk application, which is really nice. It's currently healthy and ready to go. And here is the URL without using our own custom domain, which you can do, but each resource has its own unique URL inside of AWS and inside of Azure. So in this case, it's at elasticbeanstalk.com. That does not mean that's where your application has to be referenced to by your customer. You can set up a custom DNS, domain and entry there, and you can make it, acmeinc.com or whatever your company might be. But we'll click on this just to go ahead and actually look at the application, and you'll see that we are now accessing successfully the landing page for a Node.js application running inside of Elastic Beanstalk in AWS. Now that was pretty painless. I don't know about you, but that was pretty straightforward. Is it always going to be this easy? No, it's not. But just to give you a feel for it, you can see that it was pretty straightforward to deploy. And I also want you to be aware that in CloudFormation and AWS, a stack is a definition of all the resources that were deployed. And if you delete a stack, you are going to delete all of those resources. So don't ever make that mistake of deleting a stack and not realizing that you aren't going to also delete your entire environment that you created with that stack. So you could always have multiple stacks in place, but this should bring pause to help you realize why you might want things in different accounts, so that certain individuals don't just go and delete a stack immediately on your behalf. So we're deleting this now. The delete is in progress, and we can look at the events now. The events are now showing deletes that are taking place, and it's actually deleting the sample environment right now. So that'll probably be done pretty soon. Coming back over to Azure, we can see that our Azure deployment is complete, and we can look at those details here. Let me just refresh. You can see what it did. It created a server farm, which is an app service plan. It created a site inside of that app service, and remember, we told it to dynamically create it based on a unique ID. It could have been a name that we specified, and it just defined some settings for source control inside of that site. So we can go directly to the resource group now that it created. And you can think of a resource group like a stack, kind of, but it's not. So inside of in AWS, we talked about how if you deploy a stack, the stack manages all the resources. And if you delete the stack, you delete all those resources. Not quite the same here. You have an ARM template. It deploys resources for you in one or more resource groups, depending upon the template and the complexity of it. And once it's deployed, it's done. You don't delete the deployment. You actually have to go and delete the resources by most easily deleting the resource group or groups that you've created the resources in. So it's a little different. You can't as easily delete your resources. But you'll see here, this is the resource group we created and the app service that we created inside that resource group. And we'll come in here and we'll have this really nice quick browse button, which will basically allow us to shortcut over to this URL, which, in AWS, it was called elasticbeanstalk.com. Here it's azurewebsites.net. And our unique web app here, I'll click on browse, and we should be able to see the ASP.NET landing page as soon as it jits and compiles and fires up. This usually doesn't take this long. It actually ran a lot quicker. There we go. So here is your ASP.NET sample, getting started landing page for a default ASP.NET application running inside of an Azure app service. So here's example again, how quickly we can deploy certain things to the cloud and even delete them, right? So we could delete this app service directly, or we can back ourselves out to the actual resource group and delete the entire resource group. So I just wanted to show you how quickly we can delete this entire resource group. It's asking me to enter the name to confirm, which I appreciate, versus the AWS console. It's doing a bit of a checks and balances so I don't accidentally delete it. And it actually shows me all the resources I'm about to delete. So I'll go ahead and actually delete these. And we'll see it deleting now. So we see our previously completed deployment and the resource group that we're deleting right now. And that will finish up just the same way that the CloudFormation completed deleting everything And if we go to the stack and refresh this page, looks like we still have something in progress. What do we have in progress? I think the sample application is still deleting. Not sure why it's taking longer this time, but it will be complete soon. So, so that gives us, you know, a tour of the console and the portal. I'll go ahead and take a question now if we have any, Rose. I'll be more than happy to take a question or two.
Can Azure DevOps services provisioned using ARM?
Yes, so Azure DevOps Services actually uses different approaches. It can deploy using PowerShell. It can use the Azure CLI as well as the Azure ARM templates. So yes, there is a task in Azure DevOps Services which allows you to deploy an ARM template and parameterize it and use your parameters, your pipeline variables inside of Azure DevOps Services to actually deploy those templates. It's very powerful. We use that for our customers. And it runs really well. And something, while we're on the topic of Azure DevOps Services, happens to be such a solid platform that there are many AWS customers that will actually use Azure DevOps to deploy AWS resources. And so keep that in mind as well, that it's not just a single, you know, platform choice there.
I will unmute Nicolas, who has a raised hand. So Nicolas, I don't know if you had a question. You can go ahead and talk.
What we could do, Nicholas, if you can, I'm not hearing you, but if you could type your question into the chat, and we will have one more question and answer here in about 8 minutes, 7 to 8 minutes, and we can go ahead and answer it there. I just have a couple more slides to go through, and I'll answer any remaining questions then.
Okay, Darius, you can go ahead.
Okay. I mentioned earlier that storage, there's key differences in storage between both clouds. In AWS, we have dedicated storage for disks for virtual machines with different tiers of access. We also have files, like as in file shares, NFS file shares and SMB file shares for Windows, which are running on a different infrastructure as well. Blobs are run inside of Amazon S3, and then there's hybrid options for getting storage from your on-premise environment, synchronizing your data with the cloud for backup purposes and things, or even migrating your data into the cloud. So they're all running on a different infrastructure. In Azure, let me advance to that slide. In Azure, we actually have a unified distributed storage system. And you see at the bottom, I have this very emphasized. It's a unified system. All of your Azure storage is running off the same system. So the back end is all a large cluster and set of clusters of storage that is facilitating the actual physical hardware that's storing your disk, your disks for your virtual machines. It's fully redundant. I'm by no means dismissing its durability or its fault tolerance or load balancing or anything. It's just keep in mind that it's all unified. And the Azure Files, which is the file shares for SMB, and NFS, which is in preview now, are your file shares. Blob storage is there, Azure Storage, Blob storage is there, and your hybrid options for on-prem sync, like Azure File Sync to sync your on-prem shares into the cloud. But one thing that's super important that we have to keep in mind is that because it's a unified system, it's going to behave somewhat differently than AWS in the case of your disk performance if you're attaching disks to your virtual machine. And there's a tier of storage from Azure, which we'll talk about in just a second, which runs on its own. But all of this runs on a unified system. And so we need to be mindful of that going forward here. The storage side by side, this is where you start to see the differences. And so in AWS, it's Elastic Block Store, and it's a dedicated infrastructure just for virtual machines. But in Azure, it's a shared infrastructure. And so when we're looking at back at AWS, the throttling for a workload happens at the virtual machine only, so to speak. It's predictable how much bandwidth that virtual machine can push through versus the disk is defined, but the throughput of that disk storage can be much smoother inside of AWS than it is inside of Azure. And before you say, well, that's unfortunate, I'm going to go with AWS because of this, I'm not saying that at all. It's just that you need to be mindful that whatever workload you put on Azure in its default premium and non-premium storage, that you ensure that the disk itself and the virtual machine are able to maintain the throughput that your workload demands. So if you need 5,000 IOPS for a small mid-sized database, and you need a certain amount of throughput for that, make sure that the virtual machine can handle all of the disks that you're attaching to it, and that you've accounted for that. Something also that's very important inside of Azure versus Elastic Block Store is how the throttling takes place. In AWS and Amazon, it's a smooth, predictable throttling that takes place, and it's not punitive, it's not penalizing. Whereas in Azure, the throttling that takes place, if you exceed those limits, especially at the virtual machine, it's pretty substantial. Like you'll lose 20 to 30% of your throughput momentarily until it starts to build back up. So that's why you have to provision it with sufficient overhead available to you. But there's something with Azure that we don't have with Amazon, and separate from the tier of shared storage that I previously showed here, where everything is unified. Separate from this, we have something called Azure Ultra Disk, which you can see at the bottom right. Azure Ultra Disk is dedicated, super fast SSD storage that actually exceeds the performance of AWS Elastic Block Store, as you can see by the metrics. So keep in mind, and Ultra Disk is available in certain regions, not all regions, but Ultra Disk is faster. So right as we start to think, you know what, I'm probably going to go with AWS because Azure's got some performance issues there. That's not true. It's just picking the right services across both platforms. So enough already, right? Who's the winner? So here's my take. This is just my opinion. I think it's easier to manage and secure the environment inside of Azure than it is AWS. As I mentioned, it's encrypted by default everywhere. It's a little bit more user-friendly environment, I think, from a user interface standpoint. Microsoft SQL Server workloads will definitely benefit from Azure, not only from a licensing standpoint, but feature standpoint. So that's something to keep in mind. But if you're not Microsoft-centric, keep in mind that Azure does amazing with workloads on Linux. Obviously, .NET Core is Linux-driven now, and Azure does do well with any workload. But you will generally, and this margin has shrunk, but you will generally spend less to scale certain workloads in AWS than you will inside of Azure. But again, it's starting to split hairs. This was a far more substantial difference, a few years back. I say you benefit from using both. Why not use both? And a lot of enterprises are using both or multiple clouds. So 93% of enterprises sampled this year are actually using a multi-cloud strategy. Some of those are using multiple public clouds. Some of them are using a cloud and a on-prem or a co-located facility in a hybrid approach. So just keep in mind that you really should look to use multiple clouds if you're at all able to. And why would you want to do that, and how would you do that? You can utilize Docker containers to actually go ahead and deploy across multiple clouds, including on-premise environments, by using an application server of your choice that's basically deployed and managed and orchestrated by Kubernetes. So you can run Kubernetes locally on-premise. You can run a platform as a service offering of Kubernetes like AWS EKS or Azure AKS, Azure Kubernetes Service. And ultimately, you're going to want to work with your systems admins and your DevOps team to look at these. But for deploying into multiple clouds, you might want to consider Terraform, which allows you to actually go ahead and deploy to both clouds using one definition. So let's take any additional questions that you might have. I thank you for joining us, but if we have any questions, I'd be more than happy to answer.
Darius, we have one, but I'll send it to you offline so you can take it because we need to start the next session. I'm really sorry.
Sounds great. I will take it offline. Thank you, everyone.
Okay.
Appreciate it.